So there's been a request for me to work a couple of the problems on the arc length and area sector worksheet. So I'm going to do about one question for each part, so feel free to kind of skip through as you please. So the first two parts, part 1 and part 2, are converting from degrees to radians and vice versa. So I'm going to do number 1 of part 1, which says to convert 240 degrees to radians. So I'm going to start here, and I'll write this way. So 240 degrees is something radians. So we know that our conversion factor is pi radians is 180 degrees. So we need to make sure that the unit on top here matches the unit on bottom, which means that my 180 has to go on bottom and my pi goes on top. So now I'm left with the degrees canceling out. So I have 240 pi over 180. But that seems like a pretty improper fraction, so we're going to try and simplify it. I notice that there's a 0 on top and a 0 on bottom, so now I have 24 over 18. So to check that, let's do 24 divided by 18, and I get 1.3333. So I'm going to click Math, Fraction, so number 1, I'm going to click Enter, Enter, and it tells me it's 4/3. So that simplifies to 4/3, and I still have my pi. In part 2, I'm going to convert 3.0672 radians into degrees. So this is number 3. And now I have 3.0672 radians. Again, my conversion factor is pi to 180, except this time pi has to be on bottom and 180 has to be on top. So now I'm going to multiply straight across and get 3.0672 times 180 divided by pi, which is the second power sign, and I get 175.74 degrees. For the arc length problem, I'm going to do problem number 5, which reads the following. A circle has a circumference whose length is 25 pi, so C equals 25 pi. Find the length of an arc whose central angle is 90 degrees, so theta is 90 degrees. Now, we have to remember that theta in both my sector area and arc length equation has to be in radians, so I need to convert this to radians. You might have memorized it from your unit circle, or you can do the conversion, but you end up getting pi over 2. So now I have my circumference and my theta. So, using my arc length equation, arc length is theta times r, so we need to know our r. Now, there are 2 ways to complete this problem, and I'll show you both ways. The first is to use their circumference to find r. Circumference is 2 pi r. 2 times the radius times pi gives me my circumference. So in this case, I can solve for r, because I know 2 pi r equals 25 pi. So to get r by itself, r equals 25 pi divided by 2 pi, and that gets me, the pi's go away, 12.5. So my sector area would be pi over 2 as my theta times 12.5, which is my r. When I plug that in, let's do pi divided by 2 times 12.5. My arc length is 19.63 units. However, there's another quicker way to think about this problem. The circumference, aka the entire circle, one whole circle, has a circumference of 25 pi. What fraction of a circle is 90 degrees? It's 1/4. There are 4 90-degree marks in a full circle. So I need to find the arc length of 1/4 of this. In other words, if I cut this thing into fourths, I've found my answer. So you could have done it by just taking our circumference divided by 4. Let's do that. 25 pi. I don't know if you can see my screen as I type that. 25 pi divided by 4. And I also get the same answer, 19.63 units. However you choose to do it is fine. Both ways work. Lastly, for the area sector problems, I'm going to do, again, problem number 5, which reads that a blueberry pie is made of a 10¼ inch diameter pie pan. The pie is cut into 8 equal slices. What's the area of one slice? So I need to know that my area is r² theta over 2. I know that my diameter is 10.25. And my radius then has to be half of my diameter. So 10.25 divided by 2 is 5.125. So I've gotten that far. Now we just have to find our theta because we don't know our theta. But the problem gives us that the pie is cut into 8 equal slices. So if I have a whole pie, I'm cutting it into 8 equal slices. The whole pie is 360 degrees. So each section, if it's cut into 8, is 360 divided by 8, which is 45 degrees. 45 degrees, if you remember from the unit circle, or you can convert, is the same thing as pi over 4 radians. So now I have my theta and my r. So I'm going to plug that into my area equation here. 5.125 squared times theta, which is pi over 4, all over 2. Let's plug this into my calculator now. 5.125 squared times pi over 4 divided by 2, and I get 10.31 units squared.